Hi grade 11s, the aim of this video is to summarize everything we need to know about vertical distance. I think that in functions, vertical distance is probably one of the most difficult questions, and they like to ask it, and so it's worth just having a summary and a look at what they can ask. So this question says, consider the graphs of f of x, which is equal to x plus 2, so that must be the straight line, and g of x, which is 2x squared plus 4x minus 6. Answer the questions that follow. Okay, so the first question I've got here isn't actually a vertical distance, it's a horizontal distance, because the question says, find the distance from C to D. So immediately you have to ask yourself, well, what is C and what is D? Because if I'm going to find out the distance from C to D, I'm probably going to need to find out the coordinates of C and D. And you'll notice that those are x-intercepts. So in order to find C and D, I'm going to find my x-intercept, which just means make y equal to 0, and basically solve a quadratic equation. Now, this particular quadratic equation has a common factor, so personally I would divide everything by 2, it helps a lot, and then I would factorize. Now, we don't draw to scale, but we do draw accurately, so I'm expecting one positive and one negative root. And when I factorized, if you don't like factorizing, of course you could use the formula. I got x is equal to 1 or x is equal to negative 3. So that means D must be the point 1, 0, and C must be the point negative 3, 0. Now they ask the distance from C to D, and if I just think about it, if I'm moving from C to D, I'm moving along the x-axis from minus 3 to 0, which would be 3 units, and then up another 1 unit. So CD will be 4 units. So that was quite nice. The next one says OE. Now OE is a vertical distance because it's from the origin down to my y-intercept. And so I'm thinking if I know my y-intercept, which is 0 something, I'm assuming that I will be able to know the distance from O to E because it's simply from the origin down to my y-intercept. So I think that I need to find the coordinates of E. Now that's a y-intercept, so I should be able to look at this equation, and in this form I should be able to tell my y-intercept. Reason being is x is 0 at a y-intercept, and anything times 0 is 0. So those first two terms are just 0 plus 0, and then minus 6, which means it's minus 6. Now I should have been able to see that from this format. So in future I probably wouldn't show that working because it should be obvious to me. So now I know that that's minus 6, which means the distance from the origin. Remember, distance can't be negative. So the distance from the origin down to E would be 6 units. So OE would equal 6 units. Okay, now that's something really important that I just said. Distance can't be negative. And so if you'll ever land up with a negative distance, something has gone wrong. Okay, now let's start looking at the vertical distance questions which they like to ask. Now there's 3 types of questions. So this first question is the first type of question they could give you in vertical distance. This says if OA is 2 units, find the length of AB. So if I look up here, I'm going to erase my working so far for everything. They told you that this distance here was 2 units. So if that's 2 units, that means the coordinate of A is negative 2, 0. Don't get confused that it's not positive 2. The distance is 2 units, but that'll land you up at negative 2. Now this is the first type of distance question they can give you. They are giving you the x value. Now this is the easiest of the distance questions. Now before we start looking at this one, the most important thing that you remember in all vertical distance questions is that any vertical distance is the top y value minus the bottom y value. So if I scroll up here for a second, which coordinate is on top? A is on top, so it's the y value of A in this case, which is the y value of the straight line, minus, and the bottom y value is the y value of B, which in this case is the parabola. Now, if they've given you the value of x, and you know these equations, then you pretty much know the value of y, you just have to go and find it. So if you're given the value of x, then you can find the value of y just by substituting. Why? Because I'm going to substitute into my formula. So now, to be honest, I don't even have to do this for their coordinate at A because it's on the x-axis. So I know the coordinate of A is 0, But in order to find b, I'm just going to take the formula and I'm going to say 2 times negative 2 squared plus 4 times negative 2 minus 6. And I'll be able to figure out the y value. And in this particular example, I get a y value of negative 6. So if I scroll up here, what does that mean? This means that if a is at negative 2, that this coordinate is negative 2, negative 6, which kind of makes sense because there's a symmetry happening here. Now, that's all you need. If you're given the x values, you can simply find the y values, and then you can go top y minus bottom y. Now, this bottom y was negative 6. So 0 minus negative 6 is 0 plus 6, and that is 6 units. So this is the first type of question, easiest question. If you're given the x value, all you need to use is the equation to find the y value, so you can do top y minus bottom y. So if we move on, what happens if you're not given the x value? So I've just pasted the graph again so we can look at it. It's the same question. So question C says, now if A is any point on F and B is any point on G, such that A and B are between the 2 points of intersection, so it's between there and there. So what they're saying is A could be here and then B could be there, or A could be here and then B could be there. So they're not fixing its position. They're saying anywhere between these 2 points of intersection, A and B exist. Okay, now the next thing it's told us is that AB is parallel to the y-axis. Now, why has it told us that? It's told us that because we need to know that this is a perfectly vertical line. Wherever it is, it's a perfectly vertical line. Because all vertical lines, how we work it out is we say it's top y minus bottom y. Now, if you know the y values, like we did in the previous question, you can just say 0 minus minus 6, like we knew. But deliberately in this question, I don't know where A is. It's somewhere on the straight line. And I don't know where B is. It's somewhere directly below A on the parabola. But I don't know where. So when it says find an expression that would represent the length of AB, it's exactly that. It's an expression. I can't actually find an actual value unless I know where these points are. So AB, an expression for AB, will be top y minus bottom y. And so now the question is, which y value is on the top? Now in this particular example, A is on the top, and A is on the straight line. So you just have to ask yourself, which function is on the top? And it's a straight line. Now I don't know the y value on the straight line at A because I don't know where it is. But I do know the expression for it. So if my top y is the straight line, an expression for the y value at any stage on that straight line is x plus 2. Now, if I knew the x, I could put it in and find the value, but I don't know the x. So I'm going to leave it as the expression of x plus 2. Now I'm going to subtract, and the bottom y value is the parabola. Now notice that bracket's really important because you're subtracting the whole of the parabola. And again, that's just an expression for the y value because I don't actually know the exact value. So if I simplify this a bit, I get x plus 2 minus 2x squared minus 4x plus 6. And so if I add like terms, I'm going to put my x squareds first, minus 3x plus 8. Now that's an expression for the distance between A and B. If I know the x value, I can just sub in the x value and find the length from A to B. But in this case, I didn't. So that's why it said find an expression. So that expression would tell you the distance from A to B anywhere between the 2 points of intersection. So now what D says is, considering this expression, find the x value so that the distance is 9 units. So this is the second type of question. If I give you a distance, can you work backwards to x? So the first type of question was, if I give you x, can you work out the distance? Whereas this one is working from the distance back to x. So that's why I needed an expression for this distance. So I can hopefully substitute in this distance because now I know this AB length and I can solve for what x is. So this is a question where we're working from the distance back to x. So if I know that the distance from A to B will always be equal to negative 2x squared minus 3x plus 8. I now have been given that the distance is 9. This is basically a quadratic equation. I could use the formula to solve this. If it's easy to factorize, I might as well factorize. So I'm going to bring all my x squares to this side. So plus 3x, and then 9 take away 8 is plus 1. This looks fairly easy to factorize. So I'm going to get x plus 1 plus 1. So I get that x is equal to negative a half, or x is equal to negative 1, and that those two places the distance will equal 9 units. Now if I just go up to my graph to look at where that is, that's somewhere around about here actually. So somewhere around about there, when x is negative a half, this distance will be 9 units, and then again at negative 1. So then at negative 1 again, there's actually two places, because the parabola's gone down and the straight line's gone down, there's two places where the distance happens to be exactly a half. So the first distance question was where you knew x, and so you could figure out this top y, and you could figure out this bottom y, and you could just subtract. This is the second type of question, where you don't know the top y, and you don't know the bottom y, and you don't know the x's. So what you do is you find an expression for the difference. And then, because I was told my distance, I could work backwards to the x value that make that expression. That distance equal to 9. Okay, so last question says, consider the graphs where, same graph, second same question, I just copied and pasted it. Find the length of AB when x is equal to 1. So what they're meaning is that if A is anywhere and B is anywhere, so not where I've drawn it, but where x is equal to 1, so if this was A, and this was B, what would my distance be when x is equal to 1? Now this is back to an easy question again, because any vertical distance is top y minus bottom y. And here, I don't know my top y and my bottom y, but I know the x value. And if I know the x value, I might as well know the y value, because all I have to do is substitute. So I'm going to find out f of 1, which is 1 plus 2, which is 3. And then, sorry, not f of 1, g of 1. So the parabola value at 1, so g of 1, which gives me 2 times 1 squared plus 4 times 1 minus 6, which is 0. So what I've actually found out here, I think, is that they must be talking about this point here at D, because this is the point where x is 1 and y is 0, and so my a must be directly above it, and my a value has a y value of 3. So my top y is 3, my bottom y is 0, and I get a value of 3. Now, these are basically the first two types of vertical distances you get. You do get vertical distances where you have to maximize the vertical distance, and those are the much more difficult versions of this question, and we've covered that in the past paper questions. So these are your two standard ones which we need to know. If you're given the x value, you can work out the top y, you can work out the bottom y, you can subtract. If you don't know the x value, what you can do is find an expression for the distance, and then often they're working backwards questions. Now with these ones, I'm not going to lie, they are tricky, and so the more practice you get with it, the better. And so past papers are great for that.